Hello, my name is Josh Obrecht, and I am a GIS analyst with the ACPF National Hub. In this video, we're going to discuss identifying our perennial stream network and coding it correctly in order to run the Stream Reach and Catchments tool. We have the hydro condition DEM and associated derivatives, and we've completed the first step of our three-step process by delineating a flow network. And now we're moving on to the second step, where we get to manually identify which segments are perennial by populating the StreamType field of a flow network. This is an important step as whatever we define to be a perennial network will become our stream reach, which we use in later tools such as runoff risk, the riparian assessment suite, and the nutrient removal wetland tool. So let's get started. It's important to take your time in this next step and populate the StreamType field. What you do here will determine your stream network used in all the other ACPF tools. Our goal is to properly identify perennial stream networks. Perennial streams mean streams that have continuous flow all year round. It's important to do this because management for perennial streams compared to ephemeral or intermittent streams or ditches is a different process. What we'll be doing in this step is going to the StreamType field of the flow network and then assigning a value. For example, you could use 1 to indicate perennial streams and then keep the zeros to indicate your ephemeral or intermittent streams. It's important to note that the classification value must be an integer. We can use some of the information that we already have, like the Strahler stream order, to speed up the process in classifying some of our perennial streams. However, we will still need to go in and do some manual inspection and editing to make sure everything is accurately coded. If you're still not sure how to apply this concept to map the extent of perennial streams in your watershed, try thinking of this task from an ecological rather than a hydrological perspective. One of the key reasons to install riparian buffers in a watershed is to protect the aquatic habitat that is part of the stream system. A good way to think of this is an exercise to define or predict where aquatic plants and animals can be found in a watershed. Ephemeral and intermittent streams may have filter strips installed alongside them, but these are not exactly riparian buffers, which play a role in protecting or sheltering the aquatic component of the watershed ecosystem. Basically, you are trying to define where riparian buffers can fill this specific role. We can begin editing our area flow network. To begin, we need to check that our flow network is selectable. In our table of contents on the left side of the window, we will click the selection icon, which is the blue and white square. This will show us what layers are selectable. We can see that our area flow network is turned off. We will turn this on by checking it. We will also turn off any layers that are currently on. This will reduce the amount of unwanted edits that may occur. Once this has been completed, we will change back to our layer contents by clicking the file tree icon. The first thing we will do is make our editing a little easier. We will be selecting stream segments that have a Strahler stream order of 3 or greater. We will open the attribute table for our area flow network by right-clicking on it and choosing attribute table from the menu. Strahler's stream ordering system is a well-known classification based on stream tributary relationships. The uppermost channels in a drainage network, i.e. the headwater channels with no upstream tributaries, are designated as first-order streams down to their first confluence. A second-order stream is formed below the confluence of 2 first-order channels. Third-order streams are created when 2 second-order channels join, and so on. Our attribute table contains a field titled STRAHLORD, which is for Strahler order. All of our stream segments have been given that Strahler order number, and we will utilize those to create our initial stream type designation. In our attribute table, we will click on Select by Attributes from the top of the table. In the Where statement of this window, in the Select a Field dropdown, we will choose the field Strahler. In the second dropdown, we will change is equal to is greater than or equal to. And in the third dropdown, we will click in the box and type 3. We will then click OK at the bottom of the window. This will select all of our segments with a Strahler order of 3 or higher. This will also select segments that are outside of our boundary. We will want to remove those segments that are outside of this boundary. If not already open, we will open the Map toolbar from the top of ArcGIS Pro. From the Map toolbar, we will click on Select by Location to open the Select by Location window. In the Input features, we will choose our Area Flow layer from the drop-down. We will see that this layer has our selection applied from before. We'll keep the relationship as intersect, and we'll make sure that our boundary layer is selected from the Selecting Features drop-down. From the Selection Type drop-down, we will choose Select Subset from the current selection. Once that is selected, click OK at the bottom of the Select by Location window. Our selected flow segments are now Strahler order of 3 or higher and within our boundary. Our next step is to change the StreamType field to 1 on these selected segments. In the attribute table for the area flow, which we still have open, we will right-click on the StreamType column and choose Calculate Field. The Calculate Field window will open. In this window, our area flow is selected as the input table. StreamType is also selected as our field name. Towards the bottom of the window, we can find StreamType equals. For this value, we will enter 1 and then click OK to calculate the field. In the attribute table, if we right-click on StreamType and choose Sort Descending within the menu, we can see that our selected records have a StreamType of 1. In the attribute table, click Clear to remove our selection. We will now modify this symbology to better view the data. In our table of contents, right-click on our area flow layer and click on Symbology from the menu. The Symbology window should open on the right side of our screen. In the drop-down under Primary Symbology, we will click on the second option, Unique Values. This will allow us to designate a particular color to each value. When we select Unique Values, StreamType was selected as the default field to use to symbolize. This is the field that we want. If yours does not say StreamType, choose it from the list of fields in the drop-down next to Field 1. Currently, there are no values within our classes. In the toolbar of the Classes section, the second button is titled Add All Values. We will click that, and our values of 0 and 1 have been added. For our color scheme, we will click the drop-down and check the boxes for Show Names and Show All. We will scroll down about halfway and click on Paired 3 Classes. The color scheme has now been applied to our classes, light blue for 0 and dark blue for 1. We will also make these lines slightly larger. Click on the More button in the Classes toolbar and click Format All Symbols. We will then click on the Properties tab from the top of this window and increase the line width by clicking the up arrow to 2 point. We will then click Apply at the bottom of the window. Our flow network now shows as a thicker light blue for StreamType 0 and a darker thick blue for StreamType 1. Now it's time to go segment by segment, deciding where our perennial network is or where the channels of interest are. I recommend going segment by segment, working from furthest downstream going upstream. This will help you prevent missing segments along your way. The main resource that will assist in designating our number 1 streams is imagery. Since this data is for Iowa, I've connected to the Iowa Geographic Map Server to obtain the imagery. We will also be using the hill shade in areas. I won't be showing it here, but another resource you can use is Google Maps. With the street view, you may be able to view the stream to see if it may be a perennial or require riparian analysis. I will show you some of the things to look for when going through your segments. Currently, our perennial stream, designated as 1, are in dark blue, and our intermittent, designated as 0, are in light blue. Remember that these perennial streams currently are those with a Strahler order of 3 and above, and what you'll want to do is work your way up, but this is not towards the mouth, this is just a separate section of the watershed. We'll start at the main channel of the river and work our way up this network until we reach a point where our perennial streams end. As you're working your way up, you're just going to verify that your number 1 stream values are in fact perennial streams. We can see in the imagery here that we have a very well-defined channel for these segments, and so we will continue up. These zeros do not look like they are perennial, so we will keep those as zeros. And here we come to a junction, and so we can see that the main channel is still going to be on this north side of this road. So we will take a look at the stream network on the south side of the road. Where this network is does not really appear to be perennial, and so we're going to change that designation from a 1 to a 0. We will select the segments that we will be changing the values for. As we can see, we get to a point here where the original Strahler order of 3 designation ends, so we do not need to select these as they are already 0. In our attribute table, we will change over to our selected records, which is with the icon at the lower part of the attribute table, the second one in. And now we will have our 3 selected stream segments. We will right click on the StreamType header for the field and click Calculate Field from the menu. This looks just like it did before when we calculated for StreamType 1, but for StreamType equals, we will enter 0 into that box and click OK. We will clear the selection by clicking the Clear Selection icon, which is 4 white empty boxes. And now we can see that our previous line segment that was designated as 1 is now designated as 0. We will make our way back to our junction where we had gone to the south side of the road, and we will continue back up along the north side of the road. Come to another stream segment, that one looks fine. Here's another one that is designated 1 that we will take a look at. If we turn off, we can kind of see that there is a fairly defined channel, so we will continue that as a 1. So we will make our way back up this stream segment. We come to a road, and if we turn off our network, we can see that once it gets to the road, the channel is no longer there. So what we need to do is split this line segment. And we will split this line segment at the road. We will split at the road because some of our later tools, especially the riparian assessments, will not cite practices if they intersect a roadway. Because of this, we are going to choose to split this segment where it's downstream of the road, and so there's a chance that the practices could still be cited along this segment. To split this line segment, we will turn on our Edit toolbar in ArcGIS Pro by clicking on Edit at the top of the window. We want to make sure that Select is selected, and we will click on our line segment to select it. It will turn to a bright blue. Within the Tools section of the toolbar, we want to click on Split. This tool will split one line segment into 2 at the point where you click on the line. Since we have the road and we are wanting to have our point be downstream of the road, we will find that point. We can see that our snapping for the line is still on, and we will click to split it. We can see in our attribute table that we have our two segments. And we will now go back up to our edit toolbar and click select. We want to change the value of the upstream segment to a 0 since it is currently a 1. We will click on that segment, go down to the attribute table, click in that cell, type in 0, hit enter. And if we click on our map, we can see that that line segment is now a 0, and our 1 perennial stream stops at the road. You'll want to click save up in the edit toolbar to save the edits. As we go back down to our main channel, we will continue through our stream network. Here is a segment that is designated a 0, but if we turn it off, we can still see a somewhat of a defined channel, and so we are going to want to change this segment to a 1. If we go up that segment, we come to a situation that we just did, where the stream ends at the road. We'll turn our segments back on. We have our select button selected still. We will click on that line segment to select it. Once again, we want to click on split. We'll choose a point that is downstream of the road. Click on it to split. Click on the select button. We'll click on the downstream section to select it. And then in our attribute table, we will enter a 1 into StreamType. Now that downstream section is now set as the perennial stream. We will continue through. Don't see anything to do. We have our main channel. Here we have another junction of currently set perennial. If we turn off our lines, we can see that there's some work being done here. So we'll go ahead and keep those as 1 in this channel. However, this set perennial stream over here on the east side, we will change to a 0, as there's nothing really there in the imagery to show that it's perennial. So we will click on these segments that are designated as 1, calculate field to zeros. We can see that our stream segment that is set to perennial continues down, and there's just this small little segment here, and so we're going to just leave that the way it is. We will go back up to our main channel and just continue on. It's just going to be a lot of time that needs to be taken to follow your stream network and to make sure that everything is being set to what it needs to be. We have another junction. We'll come up. We can see that everything appears to be the way it's supposed to be. We're not seeing any other junctions of perennial streams. Now we can kind of see the defined channel, and it sort of stops right here, somewhere in this forested area. So if we turn on our hillshade, we can see that we have a fairly well-defined channel that ends roughly in this area. This will be another situation where we need to split our line segment to a 0 and 1. Click on our line segment, click on split, and split it roughly where this channel ends. Since these are set to 1, we need to change the upstream value to a 0. So we will click to select it, and then choose or set the value to 0. If we go back up, we can see that there's no other ones above this junction. So we'll go back down to our main stream segment and continue on. Now we get to a point where our stream segment is entering a wetland. Since this is a wetland, it's not really a perennial stream. It is a water body. So what we're going to do is move up through the wetland and see if there's any segments that are above the wetland that need to continue to be 1s. Otherwise, we will change these wetlands to 0s. We have 2 separate segments that we will follow up. We are following this one here. If we turn it off, we kind of lose the actual channel. So we will select all of our line segments that are valued at 1. To select multiple, you will hold down the Shift key. We will follow up on this other side of the junction. We can see we're losing it already, so we're just going to go ahead and select all of these 1s, which go all the way up here past the wetland. We will now set all of these to stream type of 0. We're using the calculate field tool again. Stream type is 0. Click OK. And so now we are set. One thing I want to point out, some smaller line segments. You want to be very aware of these very small line segments, because if you do large selections, it is very easy to miss these small segments. And if these small segments are incorrectly coded, they will throw off your stream reach and will then throw off all of your other tools. Just something to be aware of. We have a couple more splits to make before we are done, and those are at our pour points. We will need to split the segments on the pour points, designating the split segment inside as 1 and outside as 0. We'll need to turn on snapping to point to accomplish this. In the Edit toolbar, we'll click on the word snapping on the snapping button. In the snapping menu, we'll turn on point snapping by clicking the first button in the menu designated by a circle. Then click Select in the Edit toolbar and click the line containing the pour point to select it. Click the Split tool in the Tools section of the Edit toolbar and move your mouse onto the pour point. Your mouse should snap to the point with the tooltip starting with our pour point layer's name and ending with point. Click the mouse to split the line. Since this is our input pour point, click Select in the Edit toolbar and click on the upstream segment. We'll need to zoom in as this is a very small segment. This segment will need to be changed to a 0 since the whole segment was coded 1 due to the Strahler order. With our attribute table set for selected records, double-click the StreamType cell and change to 0. Now we need to do our output pour point. We'll follow the same process except changing the downstream segment to a 0. There's still a chance that there may be places in the watershed that even our area flow network just doesn't extend high enough up into the watershed. What do we do in that case? Well, we basically have 2 options. We can either start over and redelineate our flow network using a lower area threshold, but if we rerun that tool, that means that everything that we've originally changed to a 1 is going to go back to being a 0. Later in this video, I will show you a multi-step way to obtain those 1s back. Secondly, we could create another area threshold network and just name it something different, say area network 2 or area network rerun, and then we would just select the section that we want to add to our current flow network using the append tool to add it to our original area of flow network. What we do not want to do ever is digitize what is missing. You never ever want to manually go in and draw a line that you would add to your area flow network. It is not going to align to your LiDAR derived flow direction, and therefore you will not be able to run future tools to get your stream reach. I'd like to point out that in this example, we were just coding our perennial stream network using a value of 1. However, you can go into a lot more detail with this. You could use a value of 1 to mean a well-developed channel, and then a value of 2 to indicate maybe a braided channel, a value of 3 to designate ditches, and then a value of 4 if you have a flow path that goes through a farm pond or maybe through a dammed reservoir. The point is that you can get very detailed with this process. Just make sure that you keep an equally detailed record of what your identification numbers mean, and make sure that you're always using integers as your identifier. I'd also like to point out that you should be very aware of landscape features and what you're coding. For example, just by looking at aerial imagery in a hillshade, sometimes a gully can appear as a well-developed channel when in fact that is a problem within the landscape that could be treated or mitigated with a conservation practice. So we would not want to code a gully as part of our perennial network because we do not want it to be excluded from future conservation practice sightings. All of this was to make sure that you are aware of your landscape features and also to feel free to get detailed and creative with your coding of the stream reach. I would like to reiterate one last time that you should never ever digitize your flow network. It will not match up to your flow direction raster, and therefore future tools will not run correctly if run at all. If you need to extend your network further up, either rerun the area threshold, saving the output using a different name, and then append that value to your original area of flow network, or just rerun and restart the coding process. Overall, this is a time-consuming process, but it's very important that we take our time through this and make sure that we've got every segment that we think could be a part of the perennial network. I will now show you the process that I use when I need to recode my data back to ones after rerunning the flow network tools. Since we found some discrepancies that we want to clear up, we will eventually need to rerun the area flow network tool again. When we rerun it again, we will lose all of our previously coded 1 perennial streams. Rather than go through all the segments again trying to determine whether they are perennial or not, I have used a multi-step process to retrieve the coded segments from an initial run. The only items that will need to be edited are the segments that we have split and any segments that may have been modified from any changes to the stream network that were made between the runs. This process can be done on either the area threshold or the Puker-Douglas stream networks. The first step needs to be done before you run the stream network tools again. We will open the catalog window on the right side of our screen by clicking the catalog tab if the catalog window is not already open. We will expand folders, our ACPF data folder, and our geodatabase. Since we applied the codes to our area flow network, we will right click on our area flow feature class and click copy from the menu. We will then right click on our geodatabase name and click paste from that menu. We now have a second area flow network with the same name, only with an _1 appended to it. Let's right click on this new area flow and click rename in the menu. The name will become editable and we will remove the _1 from the end and add original to the beginning. Since this new name now begins with original, it will be untouched when we rerun the tool. After the tool has been rerun, we have our updated stream network. We will right click on the area flow network in our table of contents and click on attribute table to open the attribute table. Let's right click on the StreamType field header and click sort descending from the menu. Since our first record in our attribute table shows a value of 0, we do not have any segments with a value of 1. We will now add our original area flow network into our map by opening the catalog window. We will then expand folders, our ACPF data folder, and our geodatabase. In our geodatabase, we will click once on our original area flow feature class, and then click and drag to add our layer into our map. We will give it the same symbology as our current area flow. Right-click on the original area flow in the table of contents and choose symbology from the window. In the top right corner of the symbology window is an icon with 3 lines, also known as a hamburger. When we click that icon, our only option is to import symbology. We will click that. We are presented with a new window to apply symbology from layer. Our original area flow network is selected in the first drop-down. We want to apply the symbology from our current area flow, so we can choose that layer from the drop-down for symbology layer. Since both of our layers have the StreamType field, the tool automatically sets those as the symbology fields. We can go down to the bottom of the window and click Run. We can close the attribute table for now. Our map now looks like it did before, with our split stream segment at the road. In our table of contents, our original flow network and our current area flow network have the same symbology. Let's turn off the original area flow. The line segment's now in light blue from the current area flow. We'll turn the original back on. The next step in this process is to select all of our original segments that were coded 1. In the map toolbar at the top of the ArcGIS Pro, we will click Select by Attributes from the Selection section. We want to select our original area flow from the Input Rows drop-down unless it is already selected. And we will want the selection type to be New Selection, so choose that from the drop-down if it is not also already selected. For our Where statement, we will choose StreamType from the Selected Field drop-down. We'll keep the second drop-down as is equal to, and in the third drop-down we will choose 1. Click OK at the bottom of the window. Our coded 1 segments from our original area flow are now selected and show as bright blue. We will now select all segments from our current area flow that are exactly the same as our original. In our map toolbar, we'll click on Select by Location. For input features, we want to choose our current area flow from the dropdown. In the relationship dropdown, we will choose are identical to. For the selecting features dropdown, we'll choose our original area flow. When we do that, we can see that it will be using our selected features. From the selection type dropdown, we will choose New Selection, and then we will click OK at the bottom of the window. The next step is to right-click on our current area flow network in the table of contents and choose Attribute Table. Our attribute table shows that 393 of our segments have been selected. These segments are the ones that are identical to our original. To code these segments as 1, right-click on the StreamType field header and click Calculate Field. We will enter 1 into the StreamType equals input box and then click OK. Let's sort our stream table descending again. We now have our segments coded as 1s at the top of our table. Since the segments we have selected are those that are equal to our original network, we need to determine those that were from splits or have changed since our original run. Right-click on our original area flow in the table of contents and click Attribute Table from the menu. The original flow attribute table shows that we have 405 selected segments. We now need to subset this selection with only those that do not match our new dataset. Once again, at the top of the ArcGIS Pro window In the map toolbar, we'll click Select by Location. For input features, we want it to be our original area flow. So select that from the drop-down unless it's already selected. In the relationship drop-down, we will choose our identical to, and in the selecting features, we will choose our current area flow unless it's already selected. Once both of these have been selected, we can see that both of them will be using a selection. And in the selection type, we will choose Remove from the current selection. We'll click OK at the bottom of the window. Any of our original segments that are equal to the new have been removed from our selection. We now have 12 selected segments from our original dataset. At the bottom of the original Area Flow Network attribute table, switch to only the selected records by clicking on the second icon of 3 blue rectangles. Instead of looking through our whole network again, we will now just need to zoom into these individual segments to make sure that we code them properly. However, when we go to edit, we will lose our selection. To resolve this, we'll change the stream type temporarily to 2. This will allow us to know where we haven't recoded our segments. With our 12 selected segments, right-click on the stream type field header and choose Calculate Field. In the stream type equals input box, we'll type 2 and click OK. We'll now clear all selections from our map by clicking Clear in the Selection section of our map toolbar. Looking at our map, our original flow is on top, and we have dark blue lines, light blue lines, and green lines. These green lines are the segments that were changed from a 1 to a 2. Turn off the original in the table of contents. We only see light blue and dark blue. The dark blue lines are those that have been given the previous code ones. Our green lines are light blue in the current flow because we need to split those so the downstream segment is a 1. Some segments will be green that do not need a split if the flow has changed paths due to a cut that you added. To recode the flows, you will need to go back and forth between the current and original to see what they should be coded. I'll now show you how to resolve one of these splits. In our map, let's zoom into the right stream that intersects the road. Click the List by Selection button in the table of contents. We only want our current and original flows selectable. Click the file tree icon to get back to the drawing order. Open the Edit toolbar at the top of ArcGIS Pro and click Select. When we click on this segment that is going through our map, the bright blue selection goes north of the road. Turn on the original flow. We are now going to split this segment. If you want to split at the same exact spot you previously did, in the Edit toolbar, click on the word Snapping on the Snapping button. We want to turn on snapping to the endpoint of a line. Click the second icon that contains a box and cross to turn on the endpoint snapping. Click on Split in the Tools section of our Edit toolbar. When we move our mouse to the area where the split will be, it will snap to the line. If we move our mouse along the segment towards the road, we will reach our original endpoint, and the mouse will snap to that location and show a tooltip ending in endpoint. Click on the line at this point. Click on our current area flow tab in the attribute table area, and click the 3 blue rectangles at the bottom of the attribute table to show our selected records. Our 1 segment has now been turned into 2. At the top of ArcGIS Pro, click Select, and then click and drag on the map across the segment that needs to be recoded, which in this instance is the downstream segment. With our current flow table showing, double-click in the stream type cell and change the value to 1. Click on the original flow tab to open its attribute table. We have that same original segment also selected. Double-click in that StreamType cell and change that value also to 1. This will indicate that we have completed the recode process on this segment and will set the original value back to 1. To go to the next segment, click the far left icon at the bottom of the attribute table to show all records of our original flow. Right-click on the StreamType header and click Sort Descending. The top of our attribute table is now populated with all of our value 2 segments. Right-click on one of the row identifiers of our records coded 2 and click Zoom to. This will zoom to our next segment where we will continue the recode process until all of these value 2 segments have been completed. To recap, we discussed how to use the area threshold network to create our perennial streams. We coded the stream type of those segments to be used for our stream reach, which will be accomplished in the next video, stream reach and catchments.